Hi and welcome to this video demonstration on multiple linear regression. I am Raghavendra, an expert in AI, ML and data engineering. In this video, we are going to learn about the implementation of multiple linear regression and evaluating the performance of multiple linear regression. In this example, we will be working with the fuel consumption dataset. This dataset is available on the Government of Canada website. The source of the dataset is available over here. This dataset has 14 features and one target, that is CO2 emissions. Here are the columns in the dataset. The problem statement is that we are going to predict the CO2 emissions of the car based on the different characteristics of the car. First, we are going to look at importing all the required libraries. First, we are going to import the pandas library. We are going to import the numpy library. From scikit-learn.linear model, we are going to import the linear regression class. And from scikit-learn.metrics, we are going to import the performance measures of mean squared error and R2 score. Let's now load the data set. To load the data, we are going to make use of pd.read_csv, and we have the entire data set in a CSV file with the name fuel_consumption. We are going to read that data set over here. Next, we are going to separate out the features and target into two different data frame objects. So X is going to comprise of all the columns excluding the target. Y is going to comprise of only the target column, which is the CO2 emissions. For the sake of simplicity, we will be dropping the columns of model, transmission type, make, vehicle class and model year. We have this command over here where we are going to drop all of these columns. Let's preview the data using the head method. Here you can observe that there is one non-numerical column among all the features. We will have to convert that to numeric using one hot encoding. So to do that, we are going to make use of the getDummies method of the pandas, which is going to perform the one hot encoding of that particular categorical string column. We are going to then concatenate these dummy columns with the original data frame X, and this is the command to do that. We are going to use pd.concat to concatenate the dummy columns into the data frame. Next, we are going to drop the string categorical column, that is fuel type, from the original data frame using the drop method. Let's preview the data. Here we can observe that all the columns are numeric in nature and the string categorical column is now encoded using one hot encoding, and these are the new columns after encoding. Next, we are going to split the data into train test. For that, we will have to import the module from scikit-learn. Scikit-learn.model selection, we will have to import the method train test split. Then we perform the split by invoking the method. So we are going to have four arrays being output: xtrain, xtest, ytrain and ytest, and the method train test split is going to take the array of features, the target, we set the test size to 0.25 and random state is set to 0. We next fit the linear regression model on our training samples. We are going to first create an instance of linear regression by calling the method linear regression and save it in an object LR. Train the model by calling the fit method on the linear regression instance by passing xtrain and ytrain to that method. Let's next check the intercept and the coefficients. intercept is available in the parameter intercept underscore, and the coefficient, which is nothing but the slope, is available in the parameter coef underscore. So here is the code to obtain the intercept and the slope. Let's print them out. The intercept has a value of 2.1491, and the coefficient, that is nothing but the slope, are a list of these values. You can see that you will have one coefficient per input feature of our data set. Here is the intercept and the coefficients. You will have one coefficient per feature. As you can see, it's a list of values. Next, let's predict the values from the trained model on an unseen test data. For that, we are going to make use of the predict method. We're going to call the predict method on the linear regression trained instance and pass xtest to that. It's going to output the predicted values, which is stored in ypred. Next, we are going to evaluate the model of the linear regression by checking the R2 score, which we had imported earlier from scikit-learn.metrics. So here we are going to call the R2 underscore score method by passing ytest and ypred, and we get an R2 score of 0.99760. We get an R squared of 99.8%, which means that 99.8% of the variance in the target column, which is CO2 emissions, is explained by our input features. In other words, if all the input features are available to us, then you'll have 99.8% of the information to make an accurate prediction about the CO2 emissions. Next, let's obtain the next performance metric, that is the mean squared error. And for that, we had as well imported the method from scikit-learn.metrics. We are going to print the mean squared error by calling the method mean underscore squared underscore error and pass the values of ytest and ypred. The mean squared error comes to a value of 7.77300. We get a mean squared error value of 7.773. This means that this is the least possible error of the best fit line for this model on the given data points. In this video, you have learned how to implement a multiple linear regression using scikit-learn, obtain the R squared and the mean squared error values, which measures the performance of the linear regression. Thanks for watching this video.